One way of solving your problems by structuring your code in a particular way is the flyweight pattern. So it's named after the boxing class that includes fighters that weigh less than 112 lbs. And the keyword to focus when discussing the flyweight pattern is less. How? Let's talk about it. So it's a solution when you want to optimize your code that is repetitive, slow, and inefficiently shares data. So it aims to minimize the use of memory in your application by sharing data as much as possible. So that shared data could be your application configuration, your application state, and other shareable things. So one thing to note here is that while implementing the flyweight pattern, it does add a teeny bit of complexity to your code, but with the performance breakthroughs that it might bring along to your application, I think it's a small concern. Now let's move on to a code example to see how you can refactor your existing application to use the flyweight pattern. So for demo purposes, I'm using the example of a library, and let's see what code we have. So for a system that implements a library, usually you'll have as many objects as many there would be books in that library. So each book would have some information. So we have the ID, title, author, checkout date, checkout member, and the due return date in that book object, right? So this is our constructor function for the book, and we have some getters and setters which we have assigned in the book prototype. So for example, we have the get title getter, we have the author getter, and we have a setter function which is update checkout status on the book. So it takes in the book ID, the checkout date, the checkout member, and what is the return date on that book. A simple general implementation of a library. The problem with this code, however, is that it would work fine for a small library, say for a school library, but what about a library that are dedicated for researchers, which have millions of books? And what about an online library? Because of the sheer amount of number of objects that would be there in the system, it'd be hard for a system to manage memory. And this is where the flyweight pattern can help us. Let's see how we can refactor this entire application and what does the flyweight pattern say about it. So according to the flyweight pattern, your applications generally would have two states, which is one is which is intrinsic to a particular area of the application, and the other state which is shareable, which could be extrinsic. So for example, when you talk about books, ID, title, and author are intrinsic properties, but the checkout date and the checkout member date and the due return date are something that aren't generally common to books. So these could be extrinsic properties. Let's remove this from the book constructors, and similarly this. Now our book function looks small. Similarly, the update checkout status, since it's not residing with a book object anymore, we'll just take this away. In order to uniquely identify books, let's add an ISBN property to our book constructor. So ISBNs are generally numbers assigned to each individual book. So every particular book title from one author would have a unique ISBN. Now let's go around doing our stuff with creating a factory function. Let's call it book factory. And since it's a factory function, we'll be expecting it to return a create book function. This create book function will check if I already have a particular book instance created, and if so, it will return that instance. If not, our book factory will end up creating a new book object and returning that object. So let's go around doing that. For that, we need existing books object, which will store all the books that could have existed. And in here, so this create book will again take the title, the author, and the ISBN, and we'll go around checking if my existing books, and let's assume that our existing books are stored with ISBNs as keys, and if I found that there's an existing book with an ISBN that was there, that was given to this Create Book Factory, then it should return me that instance of existing books. And if that is not the case, then we should have a new book created with again the title here, the author, and the ISBN. Sorry. And this new book that gets created should then be added to the existing books object, should be registered to the existing books object again with the ISBN for the new book, right? And then I should be returned with the ISBN from an existing book. So this is how our book factory looks like. Whoops. I think they should solve it on. Good. Now let's move on to see how we'll use this intrinsic object and how we can make use of the extrinsic data that is there. We'll need a book manager function here, which has the database of all the books that we have. It also takes in an ID to uniquely identify the record, and we end up doing book database ID to an object which takes in the book to record. Oh, let's not call it record, let's call it book, because it ultimately returns a book reference, and call it book, and the other properties could be the checkout date and the checkout person's name. Let's call it checkout name for now. So now we have a book object which will have a reference to the book, which is generated by checking if the book is already there. It won't create a new object, but will return the existing book object. So for 1,000 copies of the same book, we will be able to utilize the same object that was created here, and hence we get the memory improvement that we wanted by creating less objects. Also, our book manager should be a singleton so that this create book instance can be used, and all the methods that do not belong to books, that were extrinsic methods, could now be called in here. So other methods which are, for example, we change the state of the book, for example, update checkout. Can now take the checkout date and the checkout name, . which can then be used to modify information that that we have for a record. So again, we can, if passed on with an ID, we can use it to modify book database ID instance. Book database ID dot checkout date to be the new checkout date, and again book database ID dot checkout name to have the new checkout name. So all the extrinsic functions that were not related to books but were related to checkout information are now handled by our book manager and are not duplicated on each and every book instance. So this is our flyweight pattern, which helps us improve on our memory footprint.